This is video 932, and the goal of this video is to be able to graph translated parabolas written in standard form. So we briefly touched base with this in class, but we're going to look at the notes that came along with that. So you'll want your notes sheet because we're going to add the graphs and the notation into our notes. So we're going to do them simultaneously because there's a lot of similarities between these two pictures, even though one is vertically oriented and one is horizontally. So let's take a look. First of all, this vertically oriented, this is when we have an equation of the form x minus h squared equals 4p y minus k. The equation of the other one is going to have y minus k squared equals 4p x minus h. Okay, so keep in mind what's going to happen here is we'd have to have a completed square over here for the x. This one would have to y completed square. So it's all about which term is squared to decide. When x is squared, it's a normal parabola, the way we think of normal, vertically oriented. When it's y squared, then it won't be a function. It'll be a sleeping parabola, a sideways horizontal parabola. So let's take a look at what this means about all of my important points and where I can find them. So the axis of symmetry is always going to be vertical with the first equation. We have a focus point at h, comma, k plus p. Okay, so the key thing here is that it's p away. The vertex, of course I should do the vertex first, it's h, comma, k. Just like every other thing we've graphed, the vertex or the center of the graph, h, comma, k. That helps you decide where to shift it. So the focus will be P above. It's going to be P above where that vertex was. But notice in the sleeper, so now we're on the right-hand side here, the vertex will be P to the right or to the left, depending on the value of P. So we say that it's H plus P, comma K. Okay? So knowing your P value is important in order to find your vertex. So the good news is the directrix is also P away. So we're also going to go P away because those distances, remember, have to be consistent. So my directrix is going to be down P, so it's going to be K minus P. That's where my directrix will be for my vertically oriented parabola. For the other parabola, it'll be an x equation because x will be a constant value and it'll be at h minus p. Okay, so we're going P to the left of my vertex. So we're going P, H minus P. The last thing that you want to note in your note is remember this lattice rectum. So I want to draw this line in and make a note that it's always 4p in length, and that's the lattice rectum. And it always gives you 2 more points. Remember, it's connecting the focus to the parabola, and it's always going to be 4p in length. The interesting thing is why is it always 4p in length? And if you drew some triangles and thought about the geometry of it all, you would see that same thing. So this is, once again, same thing on the other side, 4p, absolute value, so that it's positive, and that's called the lattice rectum. So, the symmetry of the graph should help you with these things, and knowing the definition should also help you decide where your focus and your directrix are for all of these parabolas. So let's take a look at an example on how we're going to graph these given this information. So, find the vertex, focus, and directrix of the parabola given by x minus h squared equals 8y plus 1. The good news is this is almost written in standard form. Remember the standard form is, so I see it, x is coming first, the standard form is the following. So I'm seeing my h value and I see my k value, which tells me my vertex is 3, negative 1. But I don't see my p value yet, so I'm going to want to rewrite 8y plus 1 as 4 times 2. Y plus 1. I'm simply factoring out the 4, because now I can see my p value is 2. Okay, it's still equal, of course, to x plus 3 squared. Excuse me, x minus 3 squared. So my p-value is 2. Now I'm going to go on to the graph. I'm going to start to see where this graph is. Let's see, I have 3, -1. There's my vertex. I also have the value of my p-value, so I remember that number 1, this is vertically oriented because x is the square value, y has a power of 1. So I know that I'm going to go vertical. And since p is 2, that means my focus is 2 above. It's going to be up at 1. This is my focus. And my directrix is 2 below. So I'm going to walk 2 down. And this is my directrix. My directrix is a line y equals -3. Remember, we could have gotten that by doing k minus p. In this case, our k was 1, and our k was -1, excuse me, and our p was 2, which gives me -3. So I could have gotten it using the formula that you took in your notes. So that's my directrix and my focus. Now let's take a look at the lattice rectum, because I have 1 point on my parabola, I need at least 1 more. I know my lattice rectum will be horizontal, it'll be going in this direction, because it always goes to the vertex parallel to the directrix. But now I got to figure out how long should that line be, and so I remember that the lattice rectum is always the absolute value of 4p. So in this case, it will be 8. This p is 2, so it's the absolute value of 8, which is 8. So that means, now remember, the focuses would be in the middle of that, so that means I need to go 4 to the left and 4 to the right. So 1, 2, 3, 4 to -1. That's 1 point on my parabola, and I go 4 again to the other direction. So I'm going to end up right here. So I have 3 points on my parabola, my vertex, and the 2 endpoints in my lattice rectum. And I'm now ready to graph my parabola. Make a sketch. It's a very different sketch than what you've done in Algebra 2, where you looked at intercepts and vertices. We're purely looking at understanding where the focus and directrix are in relation to this line. Okay, you don't have to graph the lattice rectum, but you do need to graph the 2 endpoints of the lattice rectum, knowing that they're 4p apart across in the direction of the focus. So let's give this a shot on your own. See if you can graph the next one, and see if you can write a rule for the picture that's here. So your goal is to graph this. It's kind of advanced, because you will need to complete the square, okay, and then rewrite everything in standard form. Let's see if you can write a rule for this graph that you see on the right here. Okay, this rule. I will write some of these numbers down for you. This is x equals 5. The lattice rectum is at -1, 5. And down here it's at -1, -7. The vertex is at 2, -1. And the focus is at -1, -1. See if you can write a rule for this graph using those points, those key points that you see there. Bring in your questions to class. We'll definitely be going over the completing the square, but it's no different. Complete the square and then try to rewrite things in standard form.